Hi everyone. Today I'll be talking to you guys about the how to write a physics extended essay. So first of all, what is the physics extended essay? So these two paragraphs are the official IB description of a physics EE. So do pause the video and give it a read if you're interested. But the basic gist of it is that the physics EE should be an investigation on a topic of personal interest that relates particularly to physics. And the research topic, as well as your conclusion, should display some sort of personal connection to you in order to score a high mark in the extended essay. So do keep that in mind. So here's the criteria for the physics EE. It's actually divided into 11 different criteria, which all add up to 36 points. And in order to score an A, you'd have to get at least a 29. Really, just look at this criteria. It seems like a lot of stuff, but as you kind of follow the specific structure of a physics EE, you should be able to kind of tick off all the criteria quite easily. So don't worry too much about the actual criteria itself. So the first thing I'd like to talk about is just choosing your topic for your extended essay. So there are three main approaches to a physics EE. It can be experimental, data-based, and theoretical, right? And quite a vast majority of EEs are usually experimental based, but if you have a very fresh and appropriate idea for a data-based or a theoretical physics EE, by all means, you should do it. So your topic should primarily be based on physical theories of an appropriate complexity. So what I mean by that is to just not choose an extremely advanced and complicated topic, as I mentioned in the slide there. And that's just to avoid like overcomplicating things. First of all, if you choose a topic that's too complicated, it's very hard to kind of discuss it in depth enough for you to score high within the word limit. And secondly, kind of devising an experiment at a high school level based on a very complicated physical topic is very difficult. So you do want to try and keep it as simple yet quite creative. And one important thing about your topic as well is that it must have a real life application. And this is preferably should have some sort of personal connection to you, as you will see in your introduction. And secondly, I want to talk about the research question. So this is obviously going to be based on the topic you kind of decide on. But the three main kind of ingredients that must be included in your research question is the independent variable, your dependent variable, and the real life application of your investigation. Right? So for example, a good research question is, how does the maximum height that a water rocket can reach change with the variation of the initially filled amount of water? So in this research question, obviously the maximum height is the dependent variable, the initially filled amount of water is the independent variable, and the real life application involved is a water rocket. So if you follow these, like kind of those three factors closely in your research question, just make sure they're all included, you should have yourself a good research question. So this right here is the structure of the physics EE. So first you have your abstract and the table of contents. And those sections that are highlighted or bolded from introduction to evaluation, I highlighted because I wanted to point out that you don't have to follow the exact wording of these sections. So you can call it like data collection, your data presentation, or whatever it is. But it's more about the content that should be included in your extended essay that you should focus on instead of the name of the actual sections. So as long as you kind of follow the order of your contents as well as what you put in your EE, then you should be all set. Don't worry too much about the actual title of the sections. So firstly, I'll go through what you should include in the introduction. And really, this introduction should be quite straightforward because this is where you kind of discuss your research question and your real life application. So your first paragraph will most likely just be discussing why the topic you've chosen is of personal interest and why that topic is worthy of investigation. And this is where it comes in handy for you to have some sort of personal connection to your topic, because it's quite easier to explain or justify your topic once you have that personal connection and kind of the real life connection to your topic. And after you've justified your research question, your kind of topic of investigation, then you move on to the background information, where you kind of provide the necessary scientific knowledge required for just an average reader to understand what's going on in your investigation. So first you have to identify the relevant principles of physics. So for example, if you're investigating the motion of a magnet that's falling inside a copper coil, then you would kind of have to introduce the laws of electromagnetic induction and Newton's laws of motion, which would be the primary kind of theories that relate to this investigative topic. But one thing to note is that in the background information section is not where you present all your research that directly answers the research question, but rather you introduce the ideas and the topics relevant so that an average reader can kind of get an understanding of the research question instead of answering it. You also want to be presenting any information that does not really pertain to physics, that aids kind of the understanding of the reader's investigation. So, for example, if you're investigating the motion of a football to most effectively score a goal, it might be useful to kind of introduce the rules of football as well as like a typical kicker's kicking form or something like that. So the next section is the methodology, and this is where you kind of outline and explain your experimental process. So the structure of your methodology doesn't really matter. It can either be like a numbered list or it can be a paragraph form. This really just depends on your supervisor and what your supervisor prefers. One thing you should always include is a diagram, or even better, a picture of your experimental setup, because this kind of aids the reader's understanding of what you're actually doing, as well as clearly kind of presenting the process involved in your investigation. And one of the most important things about the methodology and how you score the most points in this section is your discussion of your controlled variables. And one thing to make sure is that only choose the relevant controlled variables, because you do have to justify why they have to be controlled. So like how they affect the outcome of your experiment and how you're gonna control those variables. So for example, if your controlled variables is gonna be like the temperature of the room, then you always have to kind of justify how temperature affects your data collection or your experimental process. And lastly, you also have to discuss some safety evaluations. So this obviously does not apply to data-based or theoretical EEs, but for experimental-based EEs, you definitely have to identify any safety hazards or risks involved in your methodology. Typically, this is only kind of like a paragraph or two at the end of your methodology section. So the next section is the data collection, and this will be where you kind of present your quantitative raw data as well as your qualitative observations. One thing to kind of keep in mind about qualitative observations is you really want to kind of only note the relevant qualitative observations. Firstly, because you don't want to eat up the word count, kind of noting down irrelevant qualitative observations. And secondly, these qualitative observations kind of come in handy later in your evaluation section, where you're kind of identifying some problems or weaknesses in your methodology. So you want to be able to refer back to your qualitative observations. So if you've only noted down irrelevant qualitative observations that don't really affect your data at all, it's not going to help in your evaluation. It's going to be hard for you. One thing I want to note about the raw data is that the numerical values and text inside tables, so even for process data, they do not count towards your word limit. One important thing that students often forget is also measurement uncertainties. These you always have to include in your raw data table as well as your process data. But for your process data, obviously you'd have to propagate your uncertainties according to your method. Oh, sorry. So the next section is the data analysis and conclusion. So in the data analysis and conclusion section, this is where you process your data, or you get your process data and kind of present it in a graph or a figure that's appropriate to your to the data you've collected. So in your data analysis section, essentially your aim is to derive some numerical value. For example, if you're plotting in a scatter plot graph, you want to derive the gradient of the trend line, right? So that you can refer to it in your conclusion later and kind of show how your dependent and independent variables are related to each other. So yeah, the main goal of the data analysis section is to derive a numerical value that helps you answer the research question later in your conclusion. And one of the most important things you should always remember when writing your conclusion is to have a sentence at the very start of your conclusion that directly answers your research question. So the first question of your sentence of your conclusion section should always be to answer your research question. And important thing is when you're answering that research question, you should refer back to the numerical value that you've derived in your data analysis. And not just in the first question, you should always constantly be referring to the data you've collected in your conclusion when you're presenting your findings. And the second thing you have to do in your conclusion is obviously to justify your conclusion or justify the data that you've collected and the trend you've seen with scientific research. So for example, you could have shown that X and Y are positively related to each other in your data analysis. Then in your conclusion, you would kind of put that into your investigative topic or your real life application that you introduced in your introduction. And then you would have to back up your data, your experimental data, and the trend you found with scientific research. So the next section is the evaluation. And essentially the difference between the evaluation and the conclusion is kind of wrapping up your findings and kind of presenting them and applying them to the personal real life application that relates to your investigation. Then in your evaluation is where you kind of discuss the strengths and weaknesses of your methodology and how you derive the data that you discussed in the conclusion section. So firstly, for the strengths and weaknesses, ideally you want two of your most solid strengths and weaknesses. Because firstly, you don't really want to waste a word count on identifying like numerous strengths and weaknesses. And secondly, if you do that, you kind of can't go as in depth into the discussion of your strengths and weaknesses, which is a critical mistake because you can really lose a lot of marks for having kind of a weak justification and evaluation of your methodology in your evaluation section. So you ideally just want two of your most solid strengths and two of your most solid weaknesses that you've identified. And then really the main part of this section would be to discuss the improvements to your methodology that could reduce or kind of eliminate the weaknesses you've discussed before. And then you also have to discuss some extensions to the investigation. And this is obviously not just a simple tweak to your original investigation, but rather kind of an upgrade from your investigation that really does add value to the original investigation that you've done. And what I mean by kind of not being a minor tweak would be it can't just be a simple change in the dependent variable. So for example, if your dependent variable was the amount of sugar, then you can't call like just changing it to the amount of salt instead of sugar, an extension, that would score very poorly in the evaluation criteria. Right, so some of the tips and tricks I'd like to give you about writing the physics EE is that firstly, you want to conduct enough research before you completely settle on a topic. Because going into your experimentations, you ideally want to know what the trend should look like. So for example, if your dependent variable X is supposed to show a negative correlation to Y, your independent variable. Then once you know that, going into your experiments, you know what you're looking for, you know what the data should look like. And this relates to the third point I'm going to talk about later. And it kind of keeps you on the right track for the entire experimentation process. And that kind of provides you with stability and helps a lot with time management as well. So you want to really know a lot about your topic before you settle on it. And secondly, I would definitely advise you to conduct at least a few trial experiments before you move on to actual proper trials that you're recording data for. This way you can kind of identify any problems or potential hazards in your methodology before you go into it. This provides you with like really good qualitative observations as well. So overall, it's just a good idea to conduct a few trial experiments for you to kind of get used to the equipment as well as make modifications to your methodology if necessary. Thirdly, process your data as you collect them. So this links back to the first point I was talking about. Once you conduct research before you jump into experimentations or settling on a topic, you know what your data should look like. So if you process your data as you collect them in your trials, you can kind of see that you're on the right track, right? So if your data is not what it's supposed to be, then you can kind of identify the problems you may have in your methodology and kind of improve from there. And it's always better to catch it early than conducting all your experiments for like a week and then finding out your data is rubbish. Right? And lastly, do remember that your conclusion is only worth 2 marks. And this is not to say that the conclusion is not important, because a lot of the content that you include in your conclusion is also pertaining to other criteria as well. What I want to say is that no matter what trend you acquire, there are numerous other methods or ways for you to score high on the EE. So the conclusion really is looking at like how your data like fits the scientific research you've conducted. But even if it doesn't, you can always gain a lot of points in your evaluation and your data analysis and stuff like that. So don't think it's the end of the world if your data doesn't match the scientific research you've conducted. So some possible EE ideas I want to suggest is maybe like applying Bernoulli's principle to a sailboat. So Bernoulli's principle is not within the IB syllabus, but it's kind of a not too complicated enough that you can kind of select it as your EE topic. Secondly, rotational inertia for an energy efficient fan. Once again, rotational inertia is not included in the IB syllabus, but yeah, it's not complicated enough for it to be an inappropriate topic. And thirdly, just estimating the speed of light using various different methods. So for example, like using a microwave to estimate the speed of light and kind of looking at various methods and maybe seeing which method works the best. And you can get really creative with this because obviously in a high school lab environment, you don't really have the right facilities and the equipments to very accurately estimate the speed of light. But yeah, with creative methods like using the microwave or something like that, you can get a decent enough estimate. So you guys should definitely look into it. look into these possible ideas. And what I really wanted to say from these kind of ideas is that uh, the topic or the physics principle that your topic is based on doesn't necessarily have to be within the IB syllabus, but do keep in mind to not choose a too complicated um, idea so that you get puzzled yourself or go over the word count. And that's never a good idea. So anyways, that's the end of my presentation. Thanks for watching. And if you have any questions, you can send it into the Ashtianxia social media. So thank you for listening.